Hello, so we come to another edition where we are seeing the decision trees in terms of tests, how they build upon conducting tests. So we have taken an example data set. The attributes are age, income, student, credit rating. This data set has been taken from the book by Han Campbell and by. So when we look at this attribute age, it has three categories: less than equal to 30, 31 to 40, and greater than 40. Now when we see the less than equal to 30 set, we count the number of no's. So we have 1, 2, and then we have another 3, and so we have 3 no's, and we have the number of yeses as 1 and 2. So 2 yeses. Between 31 to 40 we have yes, yes again, and 2 yeses. So we have 4 yeses and no, the no's. And for greater than 40 we have 2 yeses here, 3 yeses and 1 no. So 3 yes and 1 no. Okay, so let's just check once more. For greater than 40 we have 2 yeses and we have 3 yeses and we have 1 no. Okay, so that's it. Okay, we just realize there is a 2 no in this category. So we can make out something about this data when we look at the age attribute, that 5 samples fall along the branch of less than equal to 30, 4 samples along 31 to 40, and 5 samples again along greater than 40. So this was on the age attribute. We come to the income attribute. Income has again 3 categories: low, medium and high. We can again single out the cases for low, where we get 2 yes and 1 no here, and another yes, 3 yes and 1 no. So we get 3 yes and 1 no. Okay, for the income category medium we have the 4 yeses, 2 no's, and similarly for the high category we get this. At any point we will see that the number of samples remains 14. Okay, again for the student attribute, where we have only 2 categories, no and yes. So for no we have 2 no's, 2 yeses and 1 more no, so 3 no, 3 yes, 4 no and 3 yes. 4 no, sorry, we get 4 no and 3 yes. Okay, so we get for the student, in the no category we have 3 yeses and 4 no's, and for the yes categories we have 6 and 1. And similarly for the last credit rating we have 2 categories, fair and excellent. For the fair we can again do the count. We do the counting and we get the values as follows. For the individual, so we have seen that starting from the testing on the age attribute we get a partition. For the income attribute we get a partition. For the student we get a partition, and finally for the credit rating. So this was judging the data set based on one attribute. We now just have a look at the entire decision tree. We haven't yet seen the formal procedure, but this is what we would get for the given data set. Splitting on age, we get 3 categories, where one of them is a pure sample. On 2 branches we need more tests. So on the branch where less than equal to age less than equal to 30, we test on student, and based on this we get again pure leaves. And on the third branch, which is age greater than 40, we test on credit rating and we get pure leaves. So this example gives us another illustration of how the decision trees build on the intuitive ideas of splitting data into regions and conducting tests. See, we have seen features which are categorical. The features are important sometimes but not all the times, and that we can build a simple classifier. So we close this video with this illustration, and we'll come back with more formal methods where we deal with the selection criteria for finding the best splitting attribute, such as information gain, the Gini index or Gini purity, so it is called. One more thing is that for large data sets also, where you have very huge data sets, the method of visualization would not work, so we need more formal techniques like information gain and Gini purity. And we would also discuss the algorithms ID3 and CART regarding to the decision trees. Okay, thank you. Thanks for watching.